Section 10.4, we looked at the tangent ratio. 10.5, we're going to look at the sine and cosine ratios. So, definitions. Sine is the opposite leg over the hypotenuse, and the cosine ratio is the adjacent leg over the hypotenuse. So, you can pause this, copy down those blanks. So, SOHCAHTOA helps us remember what the ratios are. Okay, remember we already looked at tangent is opposite over adjacent. Opposite over adjacent. And now we're going to look at sine and cosine. Sine is opposite over hypotenuse. Okay? And cosine is adjacent over hypotenuse. So that's what this is. Sine opposite over hypotenuse. Cosine is adjacent over hypotenuse. Now obviously you have to be able to find the opposite, adjacent, and hypotenuse sides. Now that is based on what angle you're given. So if you're looking at this angle right here, the opposite side is across from. The hypotenuse is across from the 90-degree angle, and the adjacent side is the remaining one that's right next to this angle, and it makes up the angle. So find the sine of A and cosine of A. Remember, A is the angle. So if I'm looking at angle A, then the sine is, well, let's see, I'm going to write out SOHCAHTOA. So the sine is opposite over hypotenuse. So let's label our sides. If we're looking at angle A, the hypotenuse is across from the 90-degree angle. That one's always the easiest to recognize first. Opposite is across from the across from the angle, and then the adjacent is the remaining one. So my opposite side is 3 and my adjacent side is 4. So that means the sine of A is 3 over 4. Now let's find the cosine of A. Cosine of A, so cosine is adjacent over hypotenuse. So adjacent over hypotenuse. So my adjacent side is 4 and my hypotenuse is 5. So the cosine of A is 4 over 5. So find sine of A and cosine of A. All right, well, if we're looking at angle A. So first label the hypotenuse across from the 90-degree angle. Next label the opposite side, and then your remaining side is adjacent. So sine of A is, so I just write out SOHCAHTOA again. SOHCAHTOA. Sine is opposite over hypotenuse, which is 15 over 17. All right, I just realized I messed this up. Opposite over hypotenuse is 5. So that was incorrect. So let me correct that. Sine is 3 over the hypotenuse. That was tangent. I just recorded the tangent lesson, so whoops. Sorry, guys. So opposite over hypotenuse, adjacent over hypotenuse. So they're both over the hypotenuse, so you can see these are both 5. My bad. So opposite over hypotenuse is 15 over 17. And then let's find the cosine of A, which is adjacent over hypotenuse. So that's 8 over 17. Okay, next example. Sine of angle A. So look at angle A. Hypotenuse is always across from the 90-degree angle. Opposite is across from the angle that we're looking at. And then the remaining one is the adjacent side. So sine is opposite over hypotenuse. Opposite is 24. Hypotenuse is 25. And now let's find the cosine of A. Okay, cosine of A is adjacent over hypotenuse. So my adjacent side is 7 and my hypotenuse is 25. And then last one, so we're looking at angle A. Start by labeling the hypotenuse across from the 90-degree angle. This is the opposite side because it's opposite of the angle that we're looking at. And this is the adjacent side. So sine of angle A is opposite over hypotenuse. And we can simplify this. Let's see, 2 goes in there 4 times, 2 goes in there 5 times. And then the cosine of angle A is adjacent over hypotenuse, which we can simplify that 2 goes into 6 3 times, and 2 goes into 10 5 times. So why are the tangent, sine, and cosine separated in the lessons? There's really no good reason. Our book just does it that way, and that's why. Okay, we should have really learned them all together, but find the lengths of the legs of the triangle, round your answers to the nearest tenth. So look at the angle that you're given, the 32-degree angle. We need to find A and B. So we're going to have to set up two different trig ratios. Now, since we know angle A, I'm going to label my hypotenuse, my opposite side, and my adjacent side. Okay, hypotenuse is across from the 90, opposite is across from the angle that we know. So to find A, we have, that's the opposite side, and then we need to use a side length that we know, which is the hypotenuse. So we need opposite for A and then hypotenuse because we know what 10 is. So opposite and hypotenuse is the sine trig ratio. So opposite and hypotenuse. So the sine of my 32-degree angle equals the opposite side, which is A, over the hypotenuse, which is 10. Again, we're trying to find A, so we had to know this side, which is 10. So now to get A by itself, we need to get rid of the 10 in the denominator, which means I need to multiply both sides by 10. So A equals 10 times the sine of 32, which we can just plug in our calculator. 10, then press the sine button, then type in 32, and we get 5.299. So A equals, and we want the nearest tenth, so 5.29 is going to round to 5.3. Now we need to find B. B is the adjacent side, and we know the hypotenuse is 10. So adjacent and hypotenuse is cosine. So the cosine of my 32-degree angle equals the adjacent side B over my hypotenuse, which is 10. And same method for solving for B. We're going to multiply both sides by 10. So I'm going to type 10 times the cosine of 32 into my calculator. And we get 8.48. So rounded to the nearest tenth would be 8.5. Now, your hypotenuse always has to be the longest side. So we got 5.3 for A and 8.5 for B, and our hypotenuse is 10. So that's good. If you get something bigger than 10 for A or B, then you know you're wrong because the hypotenuse always has to be the longest side. So here let's find X and Y. So first start with the angle that you know. We know this 54-degree angle. So I'm going to label, this is a hypotenuse across from the 90-degree angle. This is the side that's opposite of the angle that I know, and this is the adjacent side. So again, let's use SOHCAHTOA to help us decide which trig functions to use to find X and Y. So I'm going to start by finding X. Okay, X is the adjacent side, and we know the hypotenuse. So adjacent and hypotenuse means that I need to use the cosine trig ratio. So the cosine of the 54-degree angle equals the adjacent side, which is X, over the hypotenuse, which is 14. Since 14 is in the denominator, we want to get rid of it by multiplying both sides by 14. So let's type in our calculator 14 times the cosine of 54, and we get 8.2. So X equals 8.2. That's good. That's not bigger than 14, so we know we're probably okay. And then let's find Y. Okay, Y is the opposite side, and we know the hypotenuse. So opposite and hypotenuse means I need to use the sine function. So the sine of my angle, 54 degrees, equals the opposite side, which is Y, over the hypotenuse, which is 14. So I'm going to multiply both sides by 14 times 14. So in my calculator, I'm going to type in 14 times the sine of 54. And that is 11.3 rounded to the nearest tenth. And that was not bigger than 14 as well, so we know that we're probably good. Now in your notes, there's 3 you try problems, which I will just go through with you. So find the lengths of the legs of the triangle. So take your known angle, label your three sides, hypotenuse across from the 90-degree angle. This is the opposite side, and this is the adjacent side. I'll write SOHCAHTOA here. SOHCAHTOA. Well, that was messy. Let's redo that. Okay, so let's find A first. A is the opposite side, and we know the hypotenuse. So opposite and hypotenuse is the sine function. So let's use sine, and this is never read as sin, just so you guys know. Never read as sin. So sine of 34 degrees equals my opposite side, which is A, over my hypotenuse, which is 7. So I'm going to multiply both sides by 7 to get A by itself. And 7 times the sine of 34 is 3.9. Okay, and now let's find B. B is the adjacent side, and then we have to use a side that we know. So let's just use the hypotenuse since they gave it to us. So adjacent and hypotenuse is the cosine function. So cosine of our 34-degree angle equals adjacent over hypotenuse. So same process, we're going to multiply both sides by 7. So if you type 7 times the cosine of 34 in your calculator, you get 5.8. Okay. All right, let's do number 16. I'm going to make this smaller. Okay. So always start with the angle that you're given and label your three sides. I always start with hypotenuse across from the 90-degree angle, the opposite side, which is across from the angle that I know that they gave me, and it's not the right angle, and then the adjacent side is the remaining one. So to find A, we have the opposite side, and they gave us the hypotenuse. Okay, so A is opposite, and then we know the hypotenuse. So opposite and hypotenuse, again, is the sine function. So sine of my 65-degree angle equals the opposite side A over the hypotenuse 12. Same process, multiply both sides by 12. 12 times the sine of 65 degrees is 10.9. And then if we're looking for B, that's the adjacent side, and we know the hypotenuse. So adjacent and hypotenuse is the cosine function. So the cosine of my 65-degree angle equals the adjacent side, which is B, over the hypotenuse, which is 12. Then to solve for B, we'll multiply both sides by 12. 12 times the cosine of 65 is 5.1. And the last one, I'll use some different colors. Okay. So we're going to start with the angle that we know, and we're going to label our three sides. Hypotenuse is across from the 90-degree angle. A is the side that's opposite of the 43-degree angle, and B is the adjacent side. So to find A is the opposite, and then they gave me the hypotenuse because they told me the hypotenuse is 5. So O and H is sine. So we're going to use the sine of my 43-degree angle, which equals opposite over hypotenuse. Multiply both sides by 5. So 5 times the sine of 43 degrees is 3.4. Then to find B, B is my adjacent side, and then we need to use a side that we know, and just use the side they gave you. We now know what A is, but what if you made a mistake finding A? So let's just use 5 because they gave us that. So that's adjacent hypotenuse, so the cosine of my 43-degree angle. My adjacent side is B, and my hypotenuse is 5. So multiply both sides by 5 to get B by itself. Plug in your calculator, 5 times the cosine of 43 degrees, and we get 3.7 for B. So again, there's no need to separate sine, cosine, and tangent. Our book just separated them by lessons. So that's it. Thank you.